Today, we go over the procedures for drawing Lewis structures. We drew some Lewis structures before. We started this chapter by showing the Lewis structure, the bond formation of hydrogen molecules, and we learned that that is the Lewis structure of hydrogen for H2. Well, drawing Lewis structures in that way only works for very simple molecules. For more complicated molecules, it is not going to work. So we're going to go through a systematic procedure for drawing Lewis structures today. Well, before that, let's make sure we do understand what Lewis structures are. We do understand what we are trying to do when drawing the Lewis structures of a molecule. Well, overall, Lewis structures reflects the electron distribution situation within a molecule. When drawing the Lewis structure, we are trying to see where are the electrons inside a molecule. Is it on a lone pair on an atom, or is it a single bond, double bond, triple bond between atoms? We're trying to figure those out. But that answer is a little too vague. It doesn't give us a clear, detailed picture of what we are trying to do. So we will come up now with a more precise description of Lewis structure. But before that, let's answer a couple more questions. First of all, why do atoms bond together to form a molecule? Good job. Become more stable. Octet rule. Atoms want to get 8 electrons in their outermost shell to become more stable. That's why they form a molecule. Then, to get 8, what are the electrons that are available for them to use in order to get 8 for all of them? Each one of them is going to get 8. What are the electrons available? Valence electrons, of course, electrons in the outermost shells of the atoms involved. Now, once we understand these two concepts, let's come back to describe what we are trying to do when we draw the Lewis structure of a molecule. Basically, when we are drawing a Lewis structure of a molecule, we are trying to assign all the available valence electrons to the atoms in the molecule so that each of the atoms is satisfied with octet rule. All right, we are going to collect all the valence electrons available, give them to the atoms within the molecule in such a way that each of the atoms is going to be satisfied with the octet rule 8. So that's our goal. Let's try to do that now. Let's start the steps for writing Lewis structures. We're going to use 2 molecules. One is water and one is phosphorus tribromide as example to go over these steps. Let's look at step number 1. Calculate the total number of valence electrons available. All right, makes sense. Since our job is to use all the valence electrons to make sure all the atoms within the molecule are satisfied, so we first need to know how many valence electrons we can use. So let's do that now together. Water, oxygen atom. Oxygen is in column number 6A. It has 6 valence electrons. Hydrogen is in column 1A. It has 1 valence electron, but there are 2 hydrogen atoms. So altogether, 6 plus 1 plus 1. Water has 8 valence electrons. Phosphorus tribromide. Phosphorus, column number 5A, 5 valence electrons. Bromine, column 7A, each one has 7. There are 3 bromine, 3 times 7, 21, 21 plus 5, 26. we have 26 valence electrons. All right, in the case of water, we need to use 8 valence electrons to make sure both hydrogen atoms and the oxygen atom are satisfied. In the second molecule, we will need to use 26 valence electrons to make sure 1 phosphorus and 3 bromine atoms, they are satisfied. That's our goal. Let's see what else. What's next? Step number 2, write the chemical symbols of the atoms in the molecule in the order in which they are bounded, and then place a single bond between them. All right, so this one is telling us put the atoms, lay the atoms out in the way they are connected and connect them with single bonds. Now here is the problem. How do we know how the molecules are connected? How do we know the sequence or the area locations they are? Yeah, if I know that, I can connect them with a single bond. That's not a problem. But how do we know that? Well, overall, of course, there are all different kinds of molecules, but there are lots of molecules. They have a unique for a pattern to form the molecule. And this is going to be true for almost all the molecules we are going to encounter in this class. What happens is always that there will be an atom that is in the center, and all other atoms will connect to the center atom. They will stay around the center atom. So for example, there may be atoms in the center, and there may be some other atoms outside it, and then you connect them with a single bond. This is what step number 2 is telling us to do. Now the key is that how do we know which atom will be the center atom? If we know that, we'll place it there, place all the other atoms around it, and link them with a single bond. That will be step number 2. All right, now let's look at how we can find the atom in the center. Number 1, usually the atom that appears only once in the formula is the center atom. Oh, by this item right away, we know oxygen will be the center atom for water, phosphorus will be the center atom for phosphorus tribromide. Well, both molecules with this guideline, it worked. There are other situations we may need more guidelines. Here are a couple more things that may help us to decide which atom will be in the center in the future. If there's a carbon in the formula, then carbon will be the atom in the center. Of course, there are exceptions, but there isn't any exception for this class. If a carbon appears in the formula, carbon will be the center atom. Hydrogen and the fluorine are never the center atoms. Hydrogen is in column number 1. It can form only one covalent bond. Fluorine is in column number 7. It can form only one covalent bond. To be an atom in the center, to connect with other thing outside, at least you need 2 bonds, or maybe even more. So hydrogen, fluorine will never be the atom in the center. They can only form one bond. Well, some other atoms like chlorine, bromine, iodine, the other atoms in the column 7A columns, usually they do not stay in the center either. Okay, at least for this class, you are not going to see them stay in the center in the Lewis structure. Okay, let's move back. Good enough for us now. So now we know for water, oxygen is the center atom. For PBr3, phosphorus is the atom in the center. Let's follow step number 2 and complete what it is asking us to do. So put the water in the center, put other atoms around it, and link them with a single bond, which is a pair of electrons. Put phosphorus in the center, put the bromines around it, and link them with a single bond. All right, can I put a bromine on the top of phosphorus? Yes, you can place it anywhere you want, as long as it is around phosphorus. All right, keep in mind, here we go. This is the end of step number 2. Let's move on to step number 3 now. Step number 3. Let me first put what we have so far at the end of step number 2. This is what we have at the end of step number 2. Number 3, add non-bonding electron pairs to the structure such that each atom bonded to the center atom has an octet of electrons. Oh, this one is telling us give outside atoms, forget about the center atom, give outside atoms 8 electrons for each. Okay, so basically, number 3 is taking care of all the atoms on the outside. Ignore the center atom. It reminds us that the octet rule for hydrogen is only 2. Hydrogen can only hold 2 electrons. So let's do that. This hydrogen, it has 2 around it right now, so don't give anything to it. This hydrogen has 2 electrons already. This hydrogen has 2 electrons around it already. It is satisfied. So this is the end of step number 3 for water. Phosphorus tribromide, 3 bromine atoms outside. Let's satisfy them with 8 electrons. A single bond is 2 electrons. Let's add 6 more to it. Now bromine has 8, happy. Bromine has 8, happy. Bromine has 8, happy. This is the end of step number 3 for phosphorus tribromide. We know what we're going to do next. Right now, all the outside atoms are happy. The only one we need to take care of is the center atom. Does that make sense to you? Of course. However, be careful. You can think about that. Okay, now let's give 8 electrons to the center atom. That sounds easy. However, you cannot do that yet because you might not have that many electrons available. This is the total number of electrons you have. You cannot just throw everyone with electrons. You may or may not have enough electrons. So let's move to step number 4 to see what it is asking us to do. Place any remaining electrons on the center atom. Oh, makes sense. If we do have enough, center will be happy. If we don't, this is all we have. Let's give all we have left to the center atom. So again, this is the end of step number 3 for water. This is the end of step number 3 for phosphorus tribromide. Now let's calculate how many electrons are remaining, how many valence electrons are remaining in each case, and we'll give all the remaining electrons to the center atom. We had 8. We have 8 altogether at the beginning. We used 2. We used another 2. We used 4. There are 4 left. So let's give the center atom, oxygen, 4 electrons. On the one on the right, we have 26 at the beginning. Now we have 8, 8, 8, 3, 8, 24. We have 2 left. So let's give the center atom 2 electrons. Give all the remaining electrons, valence electrons, to the center atom. Next, Okay, this is what we have so far. Now we ran out of electrons. Sounds like if some atoms are not happy, we need to find some other ways to make them happy. We do not have electrons anymore. So let's check if the center atom is satisfied. If the center atom has 8 electrons. If yes, we're done. Good. If yes, everyone is happy, we do not have any more electrons, we're all good. If not, this is what we need to do. Let's come back to this one later. Let's check to see the 2 molecules we are working on if they are happy. Satisfied. All atoms 8, all happy. Happy. Okay, we are done. In the 2 cases, we're done. Okay. Well, wait a minute, Lacan. What if the center atom is not happy? Well, let's use another example to review what we will do if the center atom is not happy. Let's do a Lewis structure of hydrogen cyanide. Let's follow steps. Step number 1, total number of valence electrons. Hydrogen 1, carbon 4, nitrogen 5, 1 plus 4 plus 5, 10 valence electrons. We need to use 10 electrons to make sure everyone is happy. Number 2, lay them out in the way they're connected. Connect them with a single bond. Find the center atom. The center atom is carbon. There's a carbon. If there's a carbon, carbon is the atom in the center. So let's put carbon in the center and connect them with a single bond. That's the end of step number 2. Step number 3, satisfy the outside atoms. Ignore the center atom. Outside atom, hydrogen needs 2. Hydrogen got 2 right now. Don't do anything. Nitrogen will give nitrogen 8 electrons. 1, 2, 3, 4, 5, 6, plus the bond, 8. All right, this is the end of step number 3. Step number 4, give remaining electrons to the center atom. Let's see, we have 10 at the beginning. Let's see how many have been used. 2, 4, 6, 8, 10. We used 10. There's 0 remaining. So there's nothing to give to the center atom carbon. By the end of step 4, this is still the same as what we have at the end of step number 3. Now, number 5. Now, check if the center atom is satisfied. Look at carbon. Carbon is 8. Right now it has 4. Carbon is not satisfied. If not, use 1 or more pairs of non-bonding electrons on the atoms bound to the center atom to form double or triple bond. Is it double or triple? Well, start from double. If double is not enough, go to triple. You do the same thing until the center gets 8. All right, so take a lone pair from nitrogen, put it here. Check carbon, 6 now. 6 electrons, still not happy. Not happy, keep doing. Take another lone pair, make it to triple bond. Now carbon is good. This is the end of step number 5, where all atoms are happy now. This is the Lewis structure of hydrogen cyanide. Here we go. Well, step number 6, actually, by the end of step number 5, if you didn't make any mistake, you're done. You completed the Lewis structure already. However, this number 6 asks you, let's do one more thing to make sure you're right. They ask you to check the total number of electrons in your Lewis structure to see if it is the same as the one you get in step number 1. If they're the same, you're all set. If not, somewhere there's a mistake. You may want to go over the process again. Draw the Lewis structure for each of the following molecules. All right, follow the 5 or 6 steps. Do each one of these. All right, starting from calculating the total number of valence electrons. Go through steps to each one of these. When you're done, come back to check the answer key. So pause the video and start. Here is the answer keys. Ammonia, carbon dioxide, ozone.